Hello children, so today we are going to study about meters bridge or slide wire bridge. Already we have completed basics of current, electricity and circuit theory. How to handle a circuit, okay, that already we have covered. Now we have some just like some instruments like this, okay, electrical instruments like this. So one among them is meters bridge. This is actually an application of Wheatstone's bridge. Now I will explain the instrument, how this is done. One by one we will see. So this is slide wire bridge. So this is copper strips. Actually this is connected. Okay, this copper strip, this is a battery. Here this is a switch. So if we connect this switch, current will go from here. So I2, half of the current, or not half, need not be, based on the resistance, a part of current will be flowing like this in this wire. This is a wire of uniform cross-sectional area. Another part of current will be going like this. This is not shown here, but it is going through a wire here. Then here this wire will come out. I1 will be passing to, what is this RB? This is resistance box. Okay, here we can fix resistance. Okay, so if you have attended lab practicals of physics, you will get a box there. If you screw certain things, then that will be a resistance. Okay, the certain things means if you screw 2-3 wires there, that will attach some resistance. If you remove, you can reduce resistance. If you insert, you can add resistance. So based on our wish, we can fix this resistance by using this resistance box. Okay, current will be passing. Then this current will be passing through another resistance S. Okay, then it will be going like this. This wire, its length is nothing but 1 meter. So that measurement scale is also given here. Okay, so this length, see here from this wire, a galvanometer is connected to the point D here. So till the point D, we measure this length as L. From D to 100, the remaining length we will measure as 100 minus L. So the idea is, actually I will tell the use of this one. Again we will explain. First thing is, it is based on the principle of Wheatstone's bridge. It is based on the principle of Wheatstone's bridge. So Wheatstone's bridge already we know. If a resistance is connected like this and another resistance with a galvanometer is connected like this. If we connect a battery here, this is R, S, P, Q, whatever it may be. So if we arrange this resistance in this way, R by S is equal to P by Q. If we arrange in this way, what will happen? The current through this galvanometer will be 0. If the arrangement of resistance is in this way, the ratio of this resistance and this resistance, okay, if it is equal to the ratio of this resistance by this resistance, whatever name we put, this could be R, this could be S, whatever it may be, but this by this must be equal to this by this. Okay, if we set the resistances like that, what will happen? This will become equal potential points. Okay, which all, okay, see, suppose if I put this name as A and this as D, okay, simply I am naming this as A, this is D. So current will not pass through this. This A and D will become equipotential points. That is, the voltage difference between point A and point D will become 0. Okay, the potential difference between point A and point D will become 0. Clear? So when, at what condition? R by S is equal to P by Q. If that ratio is same, then the potential at A and potential at D will become equal, so that no current will be passing through this. So what we are doing here is, suppose if we have an unknown resistance value here, okay, this meter bridge is used. What is its use? It is used to use, okay, its use is to know unknown resistance, to know unknown resistance. This is one of its use. Suppose if S is unknown resistance, we can know what is that resistance value. We will come to know that. Then to compare two resistances also, to compare two resistances, these two uses are there. Okay, to compare two resistances. What resistance? Unknown resistances. To compare two unknown resistances. So we will fix a resistance here. Okay, so this will become a resistance. Again, this is another resistance. Now then we will move this jockey. There is a jockey here. What is jockey? Jockey is a needle like thing. When we move that along the wire, when we move this along the wire, what will happen? This connection will be made. So if this length is L, this is a resistance wire actually. This is actually a resistance wire. So can I erase this? You have noted down. Okay, I am erasing this. See, suppose if this resistance is R, okay, we got this resistance as R and that resistance is S. Then this is the wire, this is actually the EMF, the battery, let it be E, and this length, okay, this is length of the wire. So if this is A, here we have the galvanometer and we are connecting like this. Now when this galvanometer current will become 0, when this galvanometer current will become 0, this by this resistance, this is also actually a resistance, no? This is also actually a resistance. How much is this resistance? A resistance is nothing but rho A divided by L. Okay, so this is a same wire, this is single wire and it's uniform, uniform cross sectional area. Its area of cross section is uniform also. So this resistance is nothing but rho L divided by A. What about this part of resistance? This is nothing but rho into 100 minus L divided by A. Total is 100. So this part is 100 minus L. This is actually L. So this resistance is rho L by A. This resistance is rho 100 minus L by A. So when the galvanometer current, the current that is passing through this will become 0. This by this is equal to this by this, just like this. R by S is equal to P by Q. Same way, R by rho L by A is equal to S by rho into 100 minus L by A. When this condition meets, what will happen? The galvanometer current will become 0. Okay. So what we do is, we will move this jockey from this side we will be moving. We will be checking the galvanometer current. Whenever this galvanometer current will become 0, we will fix this. We will fix it. when Ig becomes 0. Clear? So whenever we get Ig is equal to 0, we fix it there. After that, we will take this ratio and we will find the S resistance. Okay. So okay, please note it down. We will continue. Please note it down. Okay. So fine. So what we will do? We will do R divided by this rho L divided by A is equal to S divided by this one rho 100 minus L divided by A. Okay, so this A will be cancelled out. This row will be cancelled out. So which is non-resistance? This R is non-resistance. This is non-resistance. This one is unknown. This one we fix it. Actually, we fix it by using resistance box. This one we need to find. Okay, so unknown resistance. Okay, so what will happen? R by L is equal to S by 100 minus L. So this is the formula for finding unknown resistance. So R by L is equal to S by 100 minus L. We need not by heart anything. Just like S is equal to R into 100 minus L by L. Don't do like that, because if they interchange this, what will happen? We will get confused. So how we should follow? Just take like this. This by this length, this by this length. Bas. No need to consider A and all. Just take only this much. This resistance by this length. This resistance by this length. No RS and all. Okay. Those respective side resistance and its length, this side resistance, this side length. Okay, because if they interchange it, everything will go wrong. Okay, note down. This wire, okay, this wire should be temperature independent resistance wire. Okay, so this is maybe sometimes this may be manganese wire, because if resistance increases, if the value of this wire, resistance of this value, if it changes, then we will not get accurate value there. Okay, so manganese or Eureka, these kind of materials we use in order to make this resistance wire. We take this question. So in the given circuit, a meter bridge is shown in a balanced state. Okay, the figure is given in the question. The bridge wire has a resistance of 0.1 ohm per centimeter. Find the value of unknown resistance and the current drawn from the battery of negligible internal resistance. So here the order is changed. Normally this will be the unknown resistance, this is a known resistance. That is why we say this by this equal to this by this. This is the way to do, so that we will not make any mistake. So pause the screen and do this question. Okay, easy question, right? Once if we understand, we can do this easily. Okay, so do this. What we need to find? We need to find this unknown resistance and we need to find this current also. Okay, so X this by this, so X by 40 centimeter is equal to this by this, 6 by 60 centimeter. So X is equal to 6 into 4 divided by 6. So 6 will be cancelled off. We will be getting 4 ohm. So this thing, answer we got as 4 ohm. So the answer can be either B or D. Both are possible. Now how to find this current? Current I is equal to V by R equivalent. V by R equivalent. When there is no current that is passing through this, just like a Wheatstone's bridge, this plus this is series. Okay, this plus this can be considered as series, and this one again series. They are in parallel also. So what about this resistance? This resistance will be, we can find by using 0.1 ohm per centimeter. Okay, per centimeter 0.1 is the resistance. So for 40 centimeter, the resistance is going to be 40 into 0.1. So this is going to be 4 ohm. What about this? This resistance is 60 into 0.1. See, they have given wire has resistance of 0.1 ohm per centimeter. That is what given, per centimeter. So what is its meaning? For 1 centimeter, 0.1 ohm is the resistance. So for 2 centimeter, 0.2 ohm. For 40, 0.1 into 40. For 60, 0.1 into 60. So this is going to be 6 ohm. So what is R equivalent? R equivalent is this plus this is 10. This plus this is 10. 10 by 2, 5. Already we have done no R equivalent and all. So this is 5. So current I is equal to V by R equivalent. 10 by 5. We will be getting 2 ampere. So option D is the correct answer. Clear? Note it down. Next question. Take this one. In a meter bridge, null point is found at a distance of 60 centimeter from A. If a resistance of 5 ohm is connected in series with S, the null point occurs at 50 centimeter. So they have given the figure also. Okay, this is how. So this is A. Okay, null point is 60 centimeter from A. So this is 60 centimeter from A, the null point. Okay, right. Now this is R, this is S. Okay, if a resistance of 5 ohm is connected in series with S, with this resistance S, if a series resistance 5 ohm is connected, then the null point occurs at 50 centimeter. We need to find the values of R and S. So pause the screen, try yourself first. Okay. Okay, so got the answer? Right, we will see. Now, first initial thing is just like this, same figure. Okay, simply we are getting the null point at null point means where galvanometer current is 0. Ig is equal to 0, no deflection in the galvanometer. So R divided by 60 is equal to S divided by 100 minus 60, that is 40 centimeter. Okay, 40 centimeter. So R by this by this. So R by 60 is equal to this by this. So this is one equation, because R is also not given, S is also not given. This is one equation. Now if we can cancel all these, we can have like R is equal to this is, we can write 3 by 2 S. So let this be first equation. Now if we connect a resistance 5 ohm is connected with the series with this S, what will happen? Now the null point occurs at 50 centimeter. So that time what we get, R by 50 is equal to S plus 5. 5 ohm resistance is connected in series with the S. So S by S plus 5 divided by again 50. So this 50 can be cancelled off. This is R is equal to S plus 5. This is the second equation. So left hand side of equation 1 and 2 are same. What we can do? 3 by 2 S is equal to S plus 5. S plus 5. So 3S is equal to 2S plus 10. And when this goes to this side, S is equal to 10 ohm. Okay. Then R is equal to S plus 5. So R is equal to 10 plus 5, we get 15 ohm. So 15 ohm and 10 ohm are the answers. Clear? Take another question, students. The resistances in the two arms of meter bridge are R is equal to 5 ohm and S respectively. So when the resistance S is shunted with an equal resistance, when resistance S is shunted with an equal resistance, the new balancing length is found to be 1.5 L1, where L1 is the initial balancing length. Calculate the value of S. So suppose if we take this as S, this as R is equal to 5 ohm, then suppose if this is balancing length L1, this is 100 minus L1. Okay, this is one condition. Another condition is, if this is 5 ohm, S is shunted with equal resistance. This is S shunting, means parallelly we are connecting another equal resistance. So in that case, what is happening here? This is becoming 1.5 L1 and this length is 100 minus 1.5 L1. So these are the two conditions they have given, and we need to find the value of S. So this by this is equal to this by this, this by this is equal to this by this. This is the condition which we need to follow. So R by L1 is equal to S by 100 minus L1. R is given as 5. So 5 by L1 is equal to 100 by S by 100 minus L1. So this is the first condition based on the initial data. 5 by S is equal to 5 by L1 is equal to S by 100 minus L1. So what we will do, we will do this arrangement. 5 divided by S is equal to L1 by 100 minus L1. So let this be the first equation. Clear, based on this settings. Okay, shall I erase this one? Next condition is here, this one. So this is nothing but 5 by 1.5 L1 is equal to S by 2. When the same resistances are in parallel, S by 2 divided by 100 minus 1.5 L1. So we will make an arrangement here. We will bring this to here. So 5 divided by S by 2 is equal to 1.5 L1 divided by 100 minus 1.5 L1. Actually this 2 will go to numerator. So instead of putting here, we will put it here. This can be removed. Okay, so this is equation number 2. So equation number 1 and equation number 2 LHS are same. So by equating the right hand side, we will be able to find the value of L1. Shall I erase this? What we need to find? We need to find the value of S. We need to find the value of S. Okay, so LHS of equation 1 and 2 are same. So what we will do, equating the RHS. So L1 by 100 minus L1 is equal to this one, 1.5 L1 divided by 2 into 100 minus 1.5 L1. Okay, so this L1 will be cancelled out. Then this will bring to this side. 200 minus 3L1 is equal to, here if it goes this side, 150 minus 1.5 L1. Is it correct? 200 minus 3L1 is equal to 150 minus 1.5 L1. So bringing this to that side, bringing 150 here, we will be getting 50 is equal to, this will be going to this side, 1.5 L1. We will be getting L1 is equal to 50 by 1.5, or we can write this as 100 by 3. So L1 we got. Okay, right. So this L1 is equal to 100 divided by 3. We will put in this equation. In equation 1, we will be getting 5 divided by S is equal to, L1 is 100 by 3 by 100 minus 100 divided by 3. Okay, so what will happen? 5 divided by S is equal to 100 by 3 divided by, so this here we will multiply 300 minus 100 divided by 3. This will be cancelled out. So 5 by S is equal to 100 divided by 200. So S is nothing but, S is equal to 5 into 2, which is nothing but 10 ohm. Okay, option B. Clear? So we got two datas. Based on two datas, we made two equations. So by simplifying those two equations, we got the value of unknown resistance. Clear? So in this way, meter bridge questions can be made little bit complex, not very complex, still it is manageable, but just not an ordinary question. Okay, clear? Take another question. In a meter bridge experiment, the null point is found at 20 centimeter. Okay, null point is found at 20 centimeter. In the same experiment, when the non-resistance R is shunted by 10 ohm resistance, okay, the null point is found to be shifted by 10 centimeter. So find the unknown resistance. Say for example, if this is R, if this is S, if this is the resistance wire, so here they got 20 centimeter the null point, and so this is going to be 80 centimeter. Now what is the second data? Suppose if this non-resistance R is shunted with 10 ohm, if it is done with the 10 ohm, what happens? The null point is shifted by 10 centimeter. So null point will be shifted by 10 centimeter, only that much is done. So whether it is shifted to 30 centimeter or shifted to 10 centimeter, this is not known, this is not clearly said. So what is the answer? What will happen? This by this is equal to this by this. So initial data is R divided by 20 is equal to S divided by 80 centimeter. So this is clear. This data is very clear, no confusion. But suppose if R is, what happened? If when the non-resistance R is shunted by 10 ohm resistance, that is R into 10 divided by R plus 10 is equal to S divided by R divided by, what we will have to write here. So what happens if R equivalent increases? Okay, see, ratio of this by this must be equal to this by this. So in order to maintain that constant, this by this is equal to this by this, in order to maintain this constant, if this R increases, this length also increases. Length increases, resistance increases. So here resistance is directly proportional to length So when length increases, resistance increases. So the ratio of this by this is equal to this by this. Then when this R increases, this length also must increase. Then only this ratio can be maintained constant. If when this R is decreased, this length must be decreased. So when we connect a 10 ohm resistance in shunt, what will happen? This overall resistance will decrease. So this length should decrease. So shifting should happen lesser than 20 centimeter, not to 30. It must be 10. So what I am going to do? I will be writing here 10 centimeter, so that this is going to be S by 90 centimeter. So these are the equation 1 and 2, so that if we solve this equation, we will be getting the answers. Okay, we'll solve this. Okay, so 0, 0, centimeter, everything will be cancelled off. This is going to be 4. So we can say SC is equal to 4R. SC is equal to 4R. So this SC is equal to 4R, we can substitute here. Okay, so 10 centimeter, this can be cancelled off. 10R divided by R plus 10 is equal to 4R divided by 9. So this R can be cancelled off. This will come here. 90 is equal to 4R plus 40. So 4R is equal to 50. 4R is equal to 50. Now what they have asked to find the unknown resistance X. Find the unknown resistance X. So unknown resistance X is nothing but S. No, we have, this is what is X. Unknown resistance S. So S is equal to 4R. So this is same as S. So we will be getting 50 ohm. Dear students, take this question. In a meter bridge experiment, the circuit diagram and corresponding observation table is given in the figure. Okay, which of the reading is inconsistent? Okay, which of the following reading is inconsistent? Okay, so this is the figure. Nothing unusual, just a normal figure, resistance box, and this is a unknown resistance X. Okay, this is the resistance wire L, 100 minus L, and the battery. This is asked in 2019 mains. Okay, so but they are asking which of the reading is inconsistent. Which of the reading is inconsistent? So when we make resistance R is equal to, this is the same box. Okay, in the same resistance box, same setup only, we are doing this experiment, not in a different setup, same setup. Only thing is, we will set the resistance in the resistance box like 1000, 100, then 10, then 1. This unknown resistance we need to find. So 60 centimeter, 13 centimeter, 1.5 centimeter, 1 centimeter respectively, we will be getting the values. So out of them, one is wrong actually. That is what is they mean by the term inconsistent. Okay, this unknown resistance, if we are fixing unknown resistance, whatever resistance box value we put, once if we get a balanced system, they all should give same answers. This unknown resistance value will not change, resistance value will not change, that is constant. Okay, so one reading is inconsistent means one reading is wrong actually. Okay, it may not be balanced or some kind of mistakes will be there, that we need to find. Okay, so the real thing is R by L is equal to X by 100 minus L. So R is given in this box, length is also given, so each one we need to check. We need to check each one of them. Okay, so first one we will start from here. So here X is equal to R into 100 minus L divided by L. So using this formula we need to check the consistency. So first one, X is equal to R 1000 into 100 minus 60 is going to be 40 centimeter divided by 60. So this will be cancelled off. 2, this is 3. 2000 divided by 3. 2000 divided by 3, somewhere around 666 point something. 666.6, something like that we will be getting. Okay. So that is with the first data. Second one, x is equal to r is 100. 100 into 100 minus 13 is 87 divided by now 13. So 8700 divided by 13. 8700 divided by 13. We will be getting 669 somewhere around that value. 669. So this and this are almost okay. Somewhere near values only. Now third data, x is equal to r is now 10 into 1.5. So 100 minus 1.5 is 98.5 divided by L. So that is 1.5. So this is actually 985 divided by 15. We can take like this. So this is 656 around we will be getting. Okay, so 3 datas we got. Last data also we need to check. Okay, so fourth one I am writing here, x is equal to 1 into 100 minus L. So this is 1, so this is 99 divided by L is again 1. So this is 99 we are getting. So this is inconsistent. So fourth one is inconsistent. So fourth one is not giving the correct value. First one, second one, third one somewhere around near value. Fourth one is giving a totally different value. So that is inconsistent. That is the answer. Okay students, so that's all about meter bridge. We have covered some previous Neet questions also and previous JEE questions also. So study, try to practice more. Goodbye, good luck.